Hi everybody, this is Dark Guardsman and we're back again, and needless to say, I think I've become addicted to visualization software. So today I was getting ready to work on my homework for the day, which is basically doing a whole bunch of business analytics. This is kind of the reason why I've been doing a lot of visualization software, is that I actually have been having to do this for class as well. So I'm using that skill I'm picking up on that class to help improve the code for the mods as well. But today I was in the Discord chat for Minecraft mod development, and somebody was trying to figure out how spawning was working, so we got a visualization tool for spawning. Additional to just doing this, we actually now have grid lines for the plot. I do have to work on these more because, as you can probably tell from looking at this in the camera, this is not the greatest to stare at. I mean, even looking at my other monitor here, which actually has the recording software on it, I can see giant black lines on the screen, which shows that this is not exactly being picked up very well by the camera, and may translate over into the YouTube video of not being very good as well. I will be adding options to turn these on and off, and these will be available on all of the different types, so not only will the calculator have that accuracy, we'll also have a grid version of it as well. We'll probably put some other tools built into this, because now that I know how to do this technology-wise, it won't be too hard to implement other things like actually putting lines and everything else. But with this, we can now check the random probability of where positions are going to exist for spawning. So when Minecraft normally spawns, let me go ahead and pull the code up here and kind of explain it and go through it. So what I found, and I don't know if this is the only piece of code that actually is used for spawning, but when Minecraft goes to spawn, it goes, okay, find spawnable chunks. It'll build up a list of eligible chunks to spawn. It'll then go through, it'll check, okay, what creature are we spawning? So it's going to loop through all the different creatures. It's then going to go, okay, can we spawn peaceful creatures? Can we spawn so-and-so? And you got the point. It's got some options there. It's going to figure out, okay, how many entities can I spawn in there? It's going to check to make sure that we're not over-spawning. It's then going to randomly shuffle the chunks. It's then going to grab a chunk that it wants to spawn with, pick a random position, grab the position data from that, figure out if the block it's going to be spawning in is a normal cube. I don't even know why it even checks this, because the fact is, it's going to random it down here. So as you keep going down the list, it's going to try to loop 3 times first. It's then going to randomly loop between 0 and 4. It's then going to pick a random position between 6 and each, the X and Z, and then 1 in the Y direction in order to get a different position. It's going to check to see if that position is outside the range of the player, because it doesn't want to be spawning directly on top of the player, but it still wants to be spawned near the player. So 24 is what it ends up setting that to. It actually does 2 checks for that. It does within range 24, and then it does a square distance check, which makes no sense or something. I think actually this one is making sure that our random is not 24 outside the block position, and this one is actually the player, now that I'm looking at it. It'll do some checks really quick to make sure that, hey, we can spawn the creature, so it'll do tons of checks to make sure we can spawn it, figure out some random location, etc, etc. The validation stuff we don't really care about. The only parts we care about right now for this display system is we want to get the random chunk position, and we want to get the random position here. Now I've excluded Z off this simply because we're doing a 2D calculation, but it wouldn't be too difficult to include Z in this, and it wouldn't actually change the results anyway. Anyways, let's go ahead and do this, and we can sit here and plot the data. Now I have increased the data size points. If you've seen from over here, the data points are pretty small. I made these a little larger because the grid size is kind of pretty funky large wise. Right now I've got this manually locked to a 16 wide and 255 tall grid. That's the reason why it looks really hard to look at. The reality is I can come through here and I can change the grid spacing, and I'm definitely going to do that because even my eyes are hurting looking at this. But we can sit here and test different values. Say we want to test 100 different mob runs. So what this will end up doing, it's going to run 100 times. It's then going to loop that 3 times. It's going to loop a random amount of 4 times. So you can end up having 12 runs per colored dot. That's the reason why we're using colored dots here, is you can see the randomization of just that single instance. And then you can see where the positions end up, and they show up all over the place, and you get a kind of a picture of idea what's going on. And if you keep increasing this, you can get a really sizable distribution, figuring out what is the probability of it. And what we have figured out is this is uniformly distributed, so you have an equivalent probability of an entity spawning at any given point in the chunk from what this looks like. Although if you saw from the previous small test values, it likes to favor certain Y levels. And what I mean by favor, once it hits a Y level, it's pretty much going to distribute across that exact Y level by 1 or 2, which is kind of how the code works. You can sit here and go and figure out, yeah, that's the line right there that says that's going to be within a 1 or 2 Y levels. So there's not a lot of random once it picks a Y level and when it actually picks a result. So if it actually usually only does one run per chunk. So if we do a single run per chunk, you may not get a lot of results. We got green dots down here, which are really hard to see. So let's run that again. It's wanting to pick green multiple times here. You may even get results outside the chunk. So what this code even lets it do is because it picks a random value, and this is, we'll go random chunk position. So it picks a random chunk position. This random chunk position can be within effectively 0 to 16 of that chunk, and will be within 0 to the height of the position of that chunk. So if you have a position of say like 200, it can be between 0 and 200, but if you have another position that's between 0 and 10, it'll change this random value down here, and you'll get a completely different result. And because of the X and the Z randomization here, you can actually, when it comes down and does the other part, which is actually up here, it will actually go outside the chunk border. So you can end up with spawn points that are outside the chunk. I don't know if it actually checks for this. At some point, I assume down here, it will actually check to make sure that that chunk is loaded, so that way you aren't spawning outside the chunk range. But it will actually do all this and end up with result data, and we can plot this data on here, and we can just keep doing this and checking it and seeing how it works. And that's about it. I don't really have much else to show, just kind of doing this real quick to show this off as another use of the visualization software. We're going to keep building up uses for this. And to explain why I'm not working on ICBM right now, I've got homework to do. I've literally got an entire book to read right over here that's on statistic sampling, which is basically what we're doing over here. Hence why the relationship between the two of them. It's the most boring stuff ever, so any excuse I can get away from doing other things, I'm happy to actually work on this stuff. And this is a really good use for those people that like to build mob towers, is that you can sit here and go, okay, if my mob tower is 100 chunks wide, what is my distribution going to look like? And you can sit here and you can play with it and keep playing with it and be like doing a whole bunch of stuff. I may come in here later and I may let you actually build a mob tower in this software and then sit there and stare at it going like, okay, how does the spawn point play out? How does it actually distribute? What is my likelihood of an entity spawning here based on the type of entity? Of course, if we do that, then this whole entire validation part is going to have to get injected into the code, as we're going to have to look at creature spawn here. So there's things like slime spawn in a certain type of position. Different spawn types have limitations like light level and everything else, so we probably could map light level. I don't know if I'll go that far anytime soon, but it's there and it works. Probably end up releasing the software at some point for you guys to play with. But anyways, I'll see you guys next time with another video.